My name is Harold Nilsson. I'm the CEO of Seacross Marine, and together with Einar, we will give you a presentation on how one can use cost component to create an unmanned vessel. Okay. There are a lot of drones around. There is, however, a difference between unmanned vessels on surface or airborne, unmanned, crafts of any kind. If it's airborne, you don't have very many things that you can actually hit, as long as you keep at a high enough altitude. At sea, it's a much bigger challenge, and because you have to be involved in a lot of different things. You have to be able to make sure you can avoid collisions with other objects, such as land, underwater objects, or other vessels that are on the surface. You also need to have real-time. Thanks. You also need to have a real-time radar capability, so you can actually detect dangerous objects ahead of the vessel. Otherwise, it's impossible to drive fast with an unmanned vessel. You also need a chance to reroute and change your plans. So you need to remotely be able to actually alter whatever was planned for the unmanned vessel. So you have to be in contact with it. Actually, you cannot just send it off as an autonomous drone. If the vessel is also subject to spoofing or jamming, you have to be able to detect that, because otherwise you will just lose your vehicle. So to meet these, or take on these challenges successfully, a solution must consist of a fully remotely controlled vessel. It means that you have to be able to steer it, you have to be able to change the speed, but you also have to be able to use the autopilot remotely, real time, at all times. You have to have a capability to use the radar also real time, to be able to change the gain and the sea and the rain clutter and whatever other settings you need to have a reliable radar image under all circumstances. And you have to have, of course, real-time position, speed, and heading. And you have to be able to remotely control the entire navigation data that you have on board, but you have to be able to do it from another location. And of course, at the end of the day, you want to do something with the vessel and the data you get. So you need live streaming of video, images, target trackings. You can do soundings, whatever, depending on what kind of mission you send the unmanned vessel on. So in principle, what we want to do is to bring the total navigation system that you have on board the vessel elsewhere, virtually, so you can actually run it as if you were on board. And this is what we will show you today. And a solution of this is to duplicate whatever data you have into another system that is identical to the one you have on board. You can use it to control it from another vessel, for instance, following behind on a reconnaissance mission, or you can use it from a controlling position on land or from another vessel. What we have done is that we have used the off-the-shelf building blocks, the Seacross navigation system, the fantastic Kongsberg CTEX MBR system as a radio link, and combined it with a standard Simrad Autopilot and the Volvo Penta engines. And the reason we can do this is that we base it on the Seacross system, which is totally modular. So any system is autonomous in itself, and it lives its own life. It does cooperate with other systems on board, but you can turn any system on or off, and the other ones will continue. And this way, you can duplicate the system, so the platform actually gets quite wide, up to 32 different you can have running concurrently. It's based on a very simple principle. All the data on board in a Seacross system is eventually ending up on an Ethernet backbone. So anything connected to the system will have access to all the data available on the Ethernet. And by doing so, we can just separate one or several systems from the boat virtually, which means that if you have a Seacross system on one boat and you have a Seacross system on the unmanned boat, you use the CTEX MBR radio link, and it is as if you were on board. So it becomes a truly remotely controlled vessel that fulfills all those requirements of real-time radar control, live video, streaming, and so forth. And Einar will explain to you how this is possible, because it's a fantastic technical achievement of Kongsberg.
Hello, my name is Einar Bay. I work in Kongsberg CTEX in Trondheim, and we have developed a maritime broadband radio, and I'll just shortly give you some information about it. Let's see. Yeah, so a traditional radio, it will send out its signal in 360 degrees. What we use in the MBR is a beam-forming, a phased array solution. It means that we will control the signal of the radio to form a beam where the link is strongest. So I'll show you in another slide afterwards. So just some facts about the MBR radio. It has a 15 megabyte per second capacity. We have 50 kilometers range, ship to ship. It is IP based, and it communicates beyond line of sight. So you can actually stretch that limit. And it has a deterministic latency. That means that we can control the timing of the signals, and you can therefore share sensor data in real time. To show you quickly how it works, a traditional radar, it will send, as I said, 360 degrees on the left. And you have a limited range, and you have not as good link margin, and it's easy to pick up and easy to jam. With a phased array solution, you have a fast array that will track the target that you're sending to in a situation on the right. And it's extremely difficult to jam it. And the radio, it can switch direction of the signal 3,000 times a second. So anywhere it feels that the link is strongest, it will send the data through there. Also in a situation where you have an obstacle, like a big vessel, between the sender and the receiver, the radio will figure out the best way to send, and we can send in front or above or through the chimney or through the roof or where it finds the best solution. So it's made for an offshore environment where you have multiple vessels control around the platform, for instance, and we are totally reliable on the link not to go down. We have made 3 different versions. It's one for vertical installation, the 189, and we have a horizontal one that is the 360 degrees radio. And then we have a small radio that is contains only 4 antennas, and shown here on the right, it can also be mounted on a helmet on the soldier. Inside the big ones, there's 60 small antennas, and inside the small one, it is 4 antennas. And in this scenario that we'll show you afterwards, we have one of the 189s up at the roof and the 179 on board the vessel. This is just to show you the throughput that we have on some of our tests. This is up in the north of Norway, where we mounted the radio on the Coastal Express. And as you see, beyond the line of sight here is about 40 kilometers, and we are transmitting 15 megabytes per second out to almost 60 kilometers. So if you compare that to a traditional radio system, it's very high capacity, very strong. You won't find that anywhere else. Just some examples where they have used MBR. In Norway, the Coast Guard, NCA and NOFO are now acquiring MBR for all their vessels. In case of an oil spill or an emergency situation in Norway, they will use the system there. We have also experience from Ocean Shield with Norwegian Special Forces and autonomous operations as well. So this is basically what we're doing in Norway. We have land stations with MBRs on top, and they have a surveillance aircraft also with the MBR, and that surveillance aircraft will then work as a downlink. So whenever the plane is in the air, all the assets and vessels of the Coast Guard and also NCA and NOFO, they will have a full real-time broadband radio link. These are the 3 ground stations. So you see the UK is on the right in the same scale. So This map is covering the whole UK, and these 3 radio stations, they will give broadband radio link to these vessels and assets. And this is the coverage area when the plane is at 15,000 feet. If it takes off in Oslo, you'll have full radio coverage far out in the North Sea, and only with 3 ground stations. Denmark is also thinking of the same setup for their aircraft as well. So this is a picture from Norwegian Special Forces using the MBR solution on top of the rib there, and real-time sending data back to the frigate for the operation room. And this was in Africa, in Aden operation, and they had the real-time video out to 200 kilometers because of the special conditions there with the warm water. So whenever, the only thing that they had back in the end was they didn't have any voice coming back, but only the video was streaming. So they were very happy with the solution. As Harald says, in a situation where you have multiple assets, an autonomous vehicle, we can combine with the MBR all these sensors together and share real-time sensor data. And that's what we're doing here. We have a 50-kilometer range ship-ship. We have 30-kilometer from a drone to a drone, a small vessel with 1 meter height. And of course, if you have a drone in the air, you will exceed maybe 200 kilometers. Okay, that's what I had.
Thank you. I didn't manage to make this work, but okay. So the solution, we have a vessel right now, hovering around outside the harbor, blocking, all the lanes for the commercial traffic. What the solution we're seeing now is something like this. We have 3 systems on board the vessel, and it can be controlled either from a dedicated, position on a larger vessel, or you can just use temporarily one of the Seacross systems you have on another vessel to control the unmanned one. One can also, which is what I'm doing here, you can just run the Seacross system on any laptop or pad or anything, and then just drive it with this remote control, which is what we'll try to do. The capabilities we achieve with this very simple, in a way, combination of already available components is that we can steer the boat, full real-time steering and control. We can also use the autopilot, so we can send it off on an actual drone mission. So we can put it in a drone mode, and it can scout a route, for instance, or it will automatically send all the soundings back to the system controlling it. So you can send an unmanned vessel ahead up a river if it's uncharted, and you will know when you come following behind exactly what depths you have. But you can also control, the radar, and you can control electro-optical sensors. You can track targets and so forth. And you have, thanks to the MBR technology with 50 megabits bandwidth, you can actually stream video and electro-optical sensor data, radar, and so forth back to anyone connected like this. So this is always the scary moment when you switch the systems, but we did it several times, and of course, this time it works almost. So what's cool. What you see here now, although you don't get the full picture, so to speak, is the up here on the right-hand side, you have a real-time radar. I think we're using the FMCW radar, and it's running 48 RPM. And går från bort nu. 48 RPM. Down here we have the vessel, and here is a floor camera looking ahead, and we have an aft camera. And as you see, it's streaming live all the way. Up here is the rudder control and the rate of turn. Marcus, jag tror att du tappade kontakten här. Thank you. So what we actually see is exactly the same thing as we see on this semi unmanned vessel out here now in the harbor. We actually have one of our colleagues controlling it. So we can drive drive the boat just as if we were there. If I take this control, you see that I can change the rudder by turning it like this. He's going to get seasick, our poor colleague, but and move it any way I like, and I can drive it at any speed, or I can connect it to a route and then let it go. As you can see here also, we have we can turn on our own soundings, so we can see exactly what depths have been recorded on the way. So you see here that the Swedish Hydrographic Office is reasonably correct. What you can use this for is really for reconnaissance, or you can send it off, or you can actually do it just as a survey for soundings. And all this data can be collected remotely or locally, and then you can reuse it and add it as an extra layer on your chart.
Just add something, my background is from Navy, and in my spare time I'm a squadron leader in the Norwegian Home Guard for the vessels. And to have this kind of information coming into an ops room, if you have 3 or 4 vessels out, you can see exactly where they are, you can see what's happening. It will reduce the demand for voice communication. Also for logging what's happening afterwards, documenting if a situation escalates, and knowing that you can have real-time communication back to an operations center, for instance, if you have to use your weapons. So it's a fantastic system, and this is, in my opinion, of course, if you can control it and use it as a drone, it's good, but this kind of information as a decision support and sharing the operational picture, I think it's a great solution.
So we have 15 minutes. Thank you very much for taking your time and listening to this. If you have any more interest or questions around this, we will be in the exhibition hall where you can actually try to drive the boat yourself throughout the day, or you can go out with it and experience how it is to be driven by someone who is somewhere else. Thank you very much.